Hello and welcome to today's session for Grade 8 Elite Mathematics. The lesson for today is Lesson 4.6 Piecewise and Step Functions. This is Ms. Ruchika welcoming you to today's session, and our learning objectives for the session is to identify and graph piecewise defined functions. So let me give you the definition of a piecewise defined function. Some function cannot be described by a single expression because they are defined differently depending on the interval of x. So in simple words, a piecewise defined function is a function which is defined in pieces or defined in parts. And these functions, in your course, you will be learning piecewise linear function. So each part of the piece would be a linear function or a straight line that has a graph that is composed of some number of linear pieces. So let's see an example. In example 1, you have to graph a piecewise defined linear function, and the graph of this has two pieces. As you can see, one is piece 1, which is this part. Another is piece 2, which is this part. You also have to state the domain and the range. That means you have to tell about the input and the output of the function. So first we graph the first piece, which is this, and this is valid for x less than equal to 1. So that means we can take negative values, we can take 0, and we can take maximum 1. So let's start from the table of x and y values. So you are going to draw the graph by drawing this table of x and y values. The value which I'm choosing, I'll start with 0.1, x equal to 1 is included. Now let's create the table for using these values, and because x is less than or equal to 1, so we place a closed dot at 1 comma 6. Now you put x equal to 1. For this one, put x equal to 1 in 2x plus 4. So what do you get? 2, 1 plus 1. So this is 6. That's why the first point is 1 comma 6. So you put at x equal to 1, y equal to 6, this point a closed dot. Next point, x equal to 0, y is 4. Again, you are going to use substitution put here. So x is 0, y is 4 is this point. Next point, minus 1 comma 2, this point. Next point, minus 2 comma 0, and last point, minus 3 comma 0. Join them with a straight line, mark the arrow. So this is the graph of 2x plus 4 if x is less than equal to 1. Let's draw the graph of the second piece. For the second piece, the function is defined as minus x plus 3. So here x equal to 1 is not included. So we are going to place a circle at 1 comma 0, which is to indicate that the endpoint is not included in the graph. So we draw an open circle like this. So here if you see at 1 comma 2, you have an open circle. Next point, because you have to take x more than 1, you are going to take 2, 3, 4, 5 these points, and correspondingly the value will be minus x plus 3, which is minus 1 plus 3. So you simplify, put the value, so this is coming out to be 1. So these are the points that you get. So complete the dots and join the straight line, you will get your answer. Let's graph fx. It is in two pieces. This is the first piece or the first part of the function. So because it is piecewise function, so this is piece 1, this is piece 2. Now when we do the graph of this piecewise function, we have to do it in two parts or two pieces. So let's first graph fx equal to minus x plus 1 if x is less than equal to minus 2. So now the domain is defined as x less than equal to minus 2. So let's draw an x and y table. So different values of x will give you different values of fx, and accordingly you will have different points. So let's make this table of values. I'm going to take here 3 points to draw the graph. So because we have to take x less than -1, if we try to draw the graph, this is x-axis. I'm drawing a very rough graph here. This is y-axis. So this is -1, -2, -3, -4, -5, -6, and this is +1, +2, +3, +4, +5. 1, 2, 3, 4, 5, 6, 7. You have to make sure these are equal divisions. This is -1, -2, -3, -4, -5. So use a ruler while you are doing this graph. Okay, so x less than equal to -3, so I have to take values like -3, -4, -5. Let's take these values, and because x equal to -2 is also there, so we are going to take -2 as well. -2 is included. So what will be the function value? Now we are using minus x plus 1, so minus of -3 plus 1, minus of -4 plus 1, minus of -5 plus 1, minus of -2 plus 1. So let's find this value. So this is 3 plus 1, 4. This is 5. This is 6. And this is 3. So what is the point? -3, 4, -4, 5, ordered pairs, -5, 6, and -2, 3. Now if you look at the domain, x equal to -2 is included. So at -2, when you are taking the value 1, 2, 3, 4, 5, 6, when you are taking at -2 the value 3, it will be a closed dot. Okay, -2, 3, that's the first point. Then -3, 4, that's the next dot. -4, 5, that's the next dot, and -5, 6, that's the next dot. So these are the dots. Now you join them from the straight line. This is not exactly a straight line, but yes, you can use a ruler. So this is the graph of fx equal to -x plus 1, and this is valid when x is less than equal to -2. So this is one part of the graph. Let's draw the second piece in the next slide. Now let's draw the second piece, which is this function. This is piece 2. So we are going to draw the table of values of x. We are going to draw the table of values of fx equal to -3x minus 2, and then we'll take the ordered pair x, y. Again, we are going to take three values here. Now look at the point x equal to -2 first. At x equal to -2, what is happening? It is not included. So if it is not included, the value is minus this, which is equal to 6 minus 2 equal to 4. So the point is -2, 4, and this point is not included. So there will be an open dot, -2, 4. So there will be an open dot here, means this point is not included in the domain. Let's take some more points, -1, 0, and maybe another one more point I'm going to take here as say 2. So we'll calculate the value. -3, substitute, -1, -2, substitute 0. So this is only -2 left. Substitute 2. This is the point. So here it is 3 minus 2, 1. So the point is -1, 1. Here the point is 0, -2. And here it is -8. So 2, -8. Now let's go to the graph and draw the dots. 1 we have already done. Now -1 and 1 is the next one. It's a closed dot. 0, -2. This is the next dot. And 2, -8. So that will be somewhere here. Okay, now let's join these parts also. I'm going to join this with a blue color. So now remember, I'm drawing with a free hand. You have to use your ruler so that it's a straight line. So this is where The second part minus 3x minus 2, which is if x is greater than minus 2 is going to lie. Now, second part of the question was asking you about the domain and the range. So remember, domain is coming from x-axis, range is coming from y-axis. Domain is like your input, range is like your output. So what do you see here? All the x values starting from minus infinity to plus infinity, from even negative 2 is included here. So all real numbers would be the domain, and talking about the range also is going to be all real numbers for this question. So let's summarize the question now with the final answer. So the proper graph will look like this. Now I have done the dots with the ruler and the scale. So this is the first piece which is closed. This is the second piece of the piecewise defined function. You join the dots and there is an open dot at minus 2. The domain and range is all real numbers. So this is what is about piecewise defined function.